Hi, I'm Allen Simpson. I'm the Director of Engineering for USON, and we're going to go a little bit deeper into the programming and how you can test those in a sandbox environment on the Astra Dash. So for example, here on the home screen, we've got this generic image here shown here. So now we can go back into our program setup page. And you can see we have that same image here. So for this unique program, what we can do here is come tap that, and I already have a USB inserted for this such that I can select an image which happens to be of the part we're running. And now that image is going to appear up here in this window. If I save this program and then go back to my home screen, you can now see that this image appears in the pane that's actually running that part. It's an exact image of this part, but it can be any image that's going to be relevant for your unique application. You can put work instructions in here. You can put anything that's going to help differentiate programs for the operators, or just make this more useful in your environment. Moving on from that, we're able to go back into our program setup, and we're going to look at an additional limit. So if we wanted to have a limit in this program to make sure the part doesn't fill too fast, if it has some sort of occlusion into it, what we can do is come and expand the limits section of our fill step. And that's going to give us the two current limits that we have available for that, which is our fail below and fail above. We can expand upon that by tapping the plus and getting the additional limit window to pop up. What we're going to look for is part occlusion. So I'm going to put part OCC in here. We're going to use sensor 1, which is the only sensor we're using for this particular program. We are going to use the tared value of this since we are using the auto 0 of this. And we are going to have this part fail if this limit is breached. If you wanted to use these limits to be something more informational for you, or actually test the validity of these limits prior to fully implementing these, you can actually take no action, or just no action and move on to the next step. What this will do is let you evaluate that limit for 30, 60, 90 days, and then retrospectively look back and say, is this a valid limit or not? And then change it to fail or pass based on what your criteria is. So for this one, we're going to take no action and fail. We are going to do a fail below. So if it fails to reach its target pressure at the appropriate amount of time, it's going to fail this limit. And we are going to judge this limit based on a specific time. So I want this judged at 0.2 seconds into the fill step. Now you can set these up to have up to limits for up to 60 delta T base limits per step. These limits can also be set up to be judged at the start of the step or the end of the step as well. So I'm going to set this up and say OK, but now I need to put in my actual value. So I'm going to say if this fails to reach 2 psi in 0.2 seconds, there's something wrong with the part. So now I've developed that extra limit. Now that we've done that, we can save, go into our sandbox again, and we can actually run that same test again. So now knowing that my limit is back where it needs to be, we've just added that additional limit to the system. So we can come back to our program here and look at our actual details for this one and our profile history and see how this test is actually running. Once again, with our horizontal dashed lines here showing our additional limits. Moving on from these additional limits, we can actually also look at what we have in our advanced tab as well. So our advanced tab is really where these things come into play for your additional steps, your extra values you want to see, and very finite control of your additional I/O and electronic regulators. For those test options where you're using couples, we actually have an option here for lock on reject, which is a change in behavior when you have a part actually fail the test. So you can require an additional input to change that operator behavior to make sure the bad parts go in the reject bin. We can also set scale to limits for this, such that the graph will actually scale to the limits of your unique test, as opposed to the limits of the sensor, giving you a little bit better resolution to look from by default. We can also set up our sensor parameters, the units to be used for the specific test, and also the level of digital accuracy you would like for that as well. For step settings, Basically, with this, we can turn on what was akin to single block for CNC programming. So there's a pause at the end of each step, and it requires an additional intervention to make sure every step is done in the appropriate order, and or if there may be a need to adjust a valve, make a connection, break a connection, etc. So that's all available here as well. Our full digital I/O is also available, so you can turn on external routing valves, additional fixturing methodologies, anything like that. This is also where we find program linking. So if you would like to run a series of tests on one channel, let's say you want to run a pressure test and then link to a vacuum test pending the outcome of the pressure test, you're able to link those two programs together here based on the logic of whether it passes or fails. For regulator settings, this is really heavy on the electronic regulators, where we can set up soft starts, ramp rates, other things like that. We can also set up sample logging for this as well. If you would like to have a CSV file that comes out so you can work with this on your home computer, you can actually turn on sample logging on a program by program basis as opposed to globally, such that these can be exported out as a CSV file for review on your desktop PC. Now, you've seen a few extra things there. I do want to point out a few things about the rev control for these various different programs. We have a CRC number over here for this. That CRC number is actually an algorithmically generated unique identification based on the actual settings inside the program. So as long as that CRC number matches what you're expecting it to be from your rev control and release documentation, you will always be running the exact same program. When we talk about rev control, we've added a lot of additional features for that. So you can see this program right here is currently on Rev 10. So Rev 10, if I tap on that, will actually bring up my entire revision history for this program. Not only that, but you're also seeing the was and is of these various different programs. So if I go back to the first rev, you can see that everything is highlighted in green because that was all new programming and we had nothing in the was. If I step that up to revision 2, now you can see exactly what parameter changed between this version and the next version. And you can scroll through the entire program for each one of those. And we can carry that up through any additional revisions you'd like to see. Along with each one of these revisions, we also offer a comments field. So anyone can come in here and add additional comments to further differentiate what's going on between the various different revision levels. Beyond that, customers may also find it useful to name certain revision levels. For example, you may have revision 1, 2, 3, 4A when you release this through an ECR. And then you could carry on A1, A2, A3, revision B. So all this is available to help comply with your various different internal documentation control. Thank you for taking the time to learn a little bit more about program setup today. If you have any additional questions following this, please reach out to us directly or visit our website. We look forward to serving you in the future.